Hello and welcome to watch this video number 6 about the very basics of computing. This time we are going to study what is a programming language. So far we have been studying the imaginary computer and we have been doing and studying programs that are made of numbers, and in their executable form computer programs are just numbers. But programming with numbers, it is really quite difficult if you do it a lot, and for that reason things called programming languages have been invented. And when we use programming languages, we can do programming with the words instead of numbers, and that makes the thing a little bit easier. So in this video we are going to study a programming language which is called IML. Well, you can think that is an imaginary computer's machine level language or something like that. So that is the name of the language, and it is a kind of assembly language, and then we are going to study that what does it mean when we translate or compile a program from textual form to executable form. So my name is Kari Laitinen, and well, let's start studying then. Well, actually it would be quite nice to be on a beach today, but well, this is also quite interesting thing to study what we are going to learn today. So in earlier videos I showed you these kinds of drawings about our computer programs, so that here is with the red color we have the memory locations of the imaginary computer, and these numbers are then the executable computer program. And then I made these comments or these writings with which I describe the machine instructions and their operands. So we get a very simple programming language when we just or programming language is a thing that a computer can take a textual program, and it can transform or compile it to executable form. So a programming language is something that or we get a very simple programming language when we decide that the rules of the programming language, that we have something like these texts, and then we have a compiler or computer tool to transform them to these numbers. So we get a very simple programming language like this. And also we did have the other program that prints the text hello to the screen, and in that I also showed you that it is possible to describe these meanings for programmer, or it is possible to describe the program with these meanings for the programmer. So we get a very simple programming language when we make some rules how to write these. And I have actually made such a programming language, and that language is then called IML. So and I have also made programs, all the programs that are available in the IC8 simulator, they are also available as IML programs. So if you go to naturalprogramming.com and if you click this IC8 icon, you will find here a link. It is a small link that displays a folder, and there you will find programs like hello.iml and helloloop.iml or helloeternal.iml or abcde.iml. So these are the IML programs, the source programs. So they are called source programs, and I have downloaded, so you can download these, or you can even view them with a browser. For instance, if I click this, it shows the program in a browser. But I have downloaded these programs, and I can show you them with an editor. So I have one program here, and this is now the hello.iml. So the rules of the programming language is that, or actually we could take a look at this table here that lists all the machine instructions. So I have here the instruction codes, and then I have here these meanings for the programmer. So actually all these meanings for the programmer, they have been they are now as a kind of reserved sentences or reserved words in the IML language, so that for instance there is this load register A with value, and then we give the value or the operand like this, and then there is the output byte from register A. So you can find these same things here: load register A with value and output byte from register A. But you have to, in this IML program, you have to write these things like using the underscore characters to join the words, and you always use lowercase letters there. But actually you can write this program like this, and there is a tool to translate this program to an executable program. And also, this is also in real programming languages, that there are comments in this program. So these lines that start with a double slash character, they are comments and they are ignored, or they are not part of the actual program. So these lines are the actual program here. So these sentences or phrases, they correspond to the machine instructions, and this means, for instance, the character code of uppercase H, this means the character code of lowercase e, this means the character code of lowercase l. So you load register A with the character code of uppercase H, and then you output that register A, which results in that the character H is displayed on the screen of the imaginary computer. So this is a very simple program, and actually it is now the same program as is shown in this drawing. And I can show you that there is a compiler that can transform or compile this program to an executable form. So I have already downloaded I have here in the terminal window, I have downloaded, let's see, so I have the files hello.iml and helloloop.iml. These are the IML source programs, and I have also this executable file imlmac.up there. So I can run this. I can run this. So this imlmac is the compiler. I will put this also to the folder where these IML files are, and so I can compile it like this. So I have to invoke the compiler with a dot and slash and imlmac.up. It says that IML experimental compiler version 1.1, and it says that a file name must be given on command line. So I have to give the name of an IML file there. So let's do it. hello.iml. Well, it says something tokens 19, items 13, size 19. So I will not explain what those things mean, because this is not actually a compiler that you would start using for any serious programming. So this is just an experimental thing, and the purpose of the compiler is to show that what does it mean when I compile a program. So I will check what files are now there. So you can see that now there was this hello.iml. Now it has produced a new file called hello.ice. So, well, this ICE is something, a shortening for imaginary computer executable. So that is the result of the compilation, and that file now contains the executable form of the program. So I can display the file, and it shows the numbers. And if you compare these numbers, so there's 15, 48, 92, 15, 65, 92, 15, 60, 92. So 1, 5, 5, 4, 4, 8. So these same numbers are here. So this shows that the compiler can compile the textual program to a numerical program. So there is no, because now to execute this program, we should now type all these numbers. We should now type all these numbers to the simulator, the IC8 simulator. But because those numbers, they are already, if we take a look at the simulator and we load the hello.iml program, so you can see that those numbers are built into the simulator, but they are the same numbers as was the result of the compilation. So we also took a look at the we have also been studying this other program. I made this drawing. So this is a more complicated program. So there it uses more instructions, like this to one set memory pointer, or 2.8 load register A from memory, and 4.5 jump if register A0. So it uses more instructions. So let's take a look at this program, then how it looks like as an IML program. So it's called hello underscore loop, and again at the beginning these are comments. These lines are comments because they begin with a double slash, and well, one difference with this program and the previous program is also that there are these, I call these address names. So there is this name, beginning of program, and a colon here, display characters, and a colon here, and end of program, and colon here, and then there is the address of text. And then, but these are then the phrases that correspond to the machine instructions, and these address names then they correspond to the memory locations in the imaginary computer, or in the main memory of the imaginary computer. So for instance, this refers to the beginning of the program, or in practice it means the address 0, and this refers to the address of text, the memory location where the text begins. So you can see that in this form of the program, the text begins in address 0A, and so in practice, when this IML program is compiled, this address of text, this name, gets the value 0A. But with these names, it is easier to read the program. So we set the memory pointer to point to the first character of the text, and then we go load register A from memory. So this loads the register A from that memory address. What is the value of memory pointer, and it reads a character to register A, and jump if register A0. Well, if it is 0, it will jump to this address where there is the stop processing instruction. And then there is the instruction output byte from register A. So this displays the character, and then this increments the memory pointer by 1, and then there is the jump to address display characters, so there is a jump backwards in the program, and again the execution continues like this. So basically these instructions are executed for every character in the string that is displayed, and always it jumps to this address, and then these instructions are repeated, and in the end, because this definition then prints, or it puts the characters of this string to the memory. So it actually does this, that it prints the characters of this text to the memory like this, and it automatically puts a 0 at the end of the characters. So it automatically put the 0 there, so eventually when the 0 is read from the memory, so this jump instruction takes effect, and then the program terminates. So let's take a look at the compilation then. Compilation. So again, there are these files in the folder, and I now compile the hello underscore loop.iml. And again, it displays something, and when we take a look at the files, so we can again see that there is this file hello underscore loop.ice. And if we take a look at the content of the hello loop.ice, we can see that there are the machine instructions of the program. So again, if we compare now the numbers displayed here, so we can see that there is 2, 1, then there is A, there is 2, 8, 4, 5, 9, 9, 2, and they are exactly the same numbers as here in this handwritten version of the program. So you can see that. So this our compiler automatically can transform this textual program into this numerical one, and it shows the principle of programming. But of course, it is difficult that when we need to by hand move these machine instructions to the main memory of the computer. Yes. So we could test something like modify. For instance, if I modify this text, if I modify this text like X, Y, and Z. Oh, I'm going to be selfish. I will put Kari there. So and I save the thing, and then I compile it. And so if I now put this program to the simulator, I can print a different text. Or actually, because for instance, again, it is so that this program is already built into the simulator, so I can load the program here. So I loaded the program to the main memory, but this is now different in that when I modified the program, that it has these characters here. These characters here after the B2 instruction, there is, so I can modify this last part of the code. So I will put here, sorry, I have to put it here for B, and here I put 6.1, and here I put 7.2, and here I put 6.9, and I put also the 0 there. So I modified this program so that the ending is now as we compile it. and I will reset the processor and I will execute it with full speed. And you can see that now the text printed is Kari as I wrote into this source program. So well, of course, it is possible to we could modify this program more like. Well, let's make a quick program here. So I will save this file, save as. I will put it. test.iml. I will save it. I will take all the old instructions away. Or at least I take the comments away, and let's put there let's load register A with value, and let's put there Z. Yes. So now we load the character code of Z to the register A, and then just we here output byte from register A, so it outputs the Z, and then I will write here decrement register A. There should be this instruction there, or we can check it. So it decrements the register A by 1, and then I will take this out, we don't need this, and let's take also so you could, if you put a value to a register, you can also use numbers, or we could use set. Let's put K there, because there is one jump instruction here. Jump if registers equal. I'll take out this. So what it does now, it loads register A with value, that is the character code of Z, and register B with value K, the character code of K, and then it outputs register A, at the beginning is Z, but then it decrements register A, and jump is registers equal to the end of program, and then otherwise it jumps to address display characters. So this should now decrement this register A and until it has value that is the character code of K. So this program should now print characters from Z, X, and so to the smaller values of these character codes. So you can see if you look at the character codes, so the character code of Z is this, and then when you decrement the character code, you always go to smaller codes, and eventually you should go to the character code of K, and that should stop the program. But I will compile it, or first I save it, and then I compile it. And it's test.iml. It didn't complain anything, so it should be okay. And this is now the executable form of the program. So I should now write all these bytes to the main memory of the imaginary computer or the processor. So I will load the thing first, and then I modify the content of the main memory. So it is 15 5A 17 4B 92 1A 43 0A 41 and 4 and B2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bytes long is this program. The compiler also says that it is 11 bytes long. So I have modified the program, and now, or I have written now the program into the main memory of the IC8 simulator. I reset the processor, and now I execute it. I'll put this thing to the full speed, and let's see what happens. So it should stop when it will not output the K character. It should, the L is the last character that it should print. So this shows now that we can, I created the program by using these textual instructions and names, and then I compiled it with a compiler, and I got this numerical form of the program, or the executable form, and then I wrote this executable form of the program to the main memory, and I could make the program without thinking of the numbers, because this writing the machine instructions to the main memory of the computer, it was one kind of mechanical process. It didn't require much creativity, but this writing the actual program was required a little bit creativity, I think. So we have studied what a simple programming language is like, and we have studied what the compilation process means, and we have now then seen how we can move the program to the main memory of the simulator. So this is one step further in programming. It's easier to do programming when you can use words to construct a program, and earlier in the field of computing, it was usual to program computers like this, and they were called, these languages like this IML. It is an assembly language. It's a low-level language, and later on we will also study a little bit what are the higher level languages are like. And in real, because now I have the instructions in this IML language, they are like long. So they are long sentences or phrases. So in the assembly languages that were used during the early days of computing and they are still used in some special cases. So in these real assembly languages, they are these instructions. They are usually some abbreviations or acronyms, like this could be something like LDA or something. But at least these are more understandable than the traditional abbreviations. Okay, so I thank you for your attention today, and we'll meet still in some more videos. So thank you and bye.